This is a video of just examples of implicit differentiation. If you're looking for a deeper explanation of how it works, I cover that in one of my lesson videos, which I highly recommend you check out if you need more of a breakdown. So I'm going to go through just these three examples in this video. So if there's a particular example you want to see, you can forward to it, or you can always use this as a way to quiz yourself. Pause the video here, hit play when you're ready to see the solutions. So starting with A here. Okay, so with implicit differentiation, we're basically just going to start taking derivatives all the way through. The left side is at least easy peasy on the left side, so it's 2x. And now for the right side, so I have to use quotient rule here, right? All right, so quotient rule, that means that I have to take the derivative of the top times the derivative of the bottom. So as I take the derivative of the top, the derivative of 3 minus y, this is going to come out to -1. But that -1 comes from taking the derivative of -y, right? So this will be -1 dy dx, or y prime, whichever you prefer, times the bottom. And then for the next part of this, I leave the top alone. And for the bottom part, taking the derivative of this, so the derivative of 4x is just 4. And then the derivative of 5y is going to be 5, except now I took the derivative of y, so I'm going to write dy dx here. Sorry, I have to cram that. I'll try to space it out in the next part. All of this over 4x plus 5y squared. Okay, so now we get to go through the super fun of trying to get dy dx by itself. So one thing you want to do is just notice where that actually occurs. And by the way, this is why I prefer writing dy dx instead of y prime, because with a problem like this, I think that y prime can get lost in the symbols. Dy dx is a lot harder to lose. So I talked about in my previous video, you could use either, but I really think dy dx is a stronger choice. Okay, so the only way that you're going to get dy dx by itself here is if you distribute. So you're going to have to distribute this into this set of parentheses, and then here you're going to have to FOIL kind of this whole little part out, right? Okay, so let's do that. So I've got 2x equals -4x times dy dx minus 5y dy dx. So notice I literally just distributed this here, and then I moved the dy dx just to the end, just because that's where I like to put it. You could also put it at the beginning, whatever works for you. And now let's work on this little mess over here. So this is going to be minus, and I'll use a square bracket. Okay, so I've got 3 times 4 is 12. 3 times 5 dy dx is going to be 15 dy dx minus 4y, and then all of this minus 5y dy dx. And so now notice I've still got to distribute the negatives. So let's just keep going with this. And all of this is still divided by 4x plus 5y squared. So I could use some room, so I'm going to clear some space. So now I've got 2x equals -4x dy dx minus 5y dy dx. And I'm going to put all the dy dx's together. So this is going to become plus 5y dy dx, and then minus 15 dy dx, and then minus 12 plus 4y, and then all of this is still over that denominator. So as you can see, sometimes these problems take up a lot of paper, but now we have some good news out of this, right? So I can drop these 5y's. So I'll go ahead and I'll do that. Those will fall out. And so making a little more space again, this will now come out to 2x equals, so I'm going to go ahead and factor out dy dx here. So -4x minus 15 minus 12 plus 4y. And one other thing I'm going to do, so these parts that have the dy dx, I'm going to make this into its own fraction. So this is over 4x plus 5y squared, and then this is over, let's see, 4x plus 5y squared. Oops, I have messed up where I put that. It's 5y squared, 5y squared. And then one other thing I have to be careful of with this. So be careful with where you're putting this minus sign now if you're going to break these up into two separate fractions. So what I want to do actually is I'm going to reverse the order of the top here so that I don't get confused. So I'm going to add these two fractions, but I'm going to write this as 4y minus 12. So just notice where that comes from. So that's just me honoring the symbols that were up here to begin with. So now I have no confusion here. And so now I'm in a much better position to actually finish this problem, because I can go ahead and subtract this over to the other side, and then I can just kind of multiply by the reciprocal. So making a little more space again, I'm going to have 2x minus 4y minus 12 over 4x plus 5y squared, and then all of that's equal to negative 4x minus 15 over 4x plus 5y squared dy dx. So now if I just multiply by the reciprocal here, so I get this really gnarly looking answer. This is going to be 2x minus 4y minus 12 over 4x plus 5y squared, and then all of this times this reciprocal of 4x plus 5y squared over negative 4x minus 15. Whew. Okay, and now we are good. Now, if you wanted to go farther with this, you could actually try to get a common denominator and you could distribute this in. I'm going to omit that step here, but you can technically go farther with this. But I think that this really gets kind of the point across. Okay, so moving on to b here. So same idea. Let's just start taking derivatives. So the derivative of x to the 6th is going to be 6x to the 5th. Now here I'm going to have to use the chain rule to start. So the outermost function is cosine. So the derivative of cosine is negative sine. So this whole thing will become positive sine. Leave the inside alone, so times xy. And now I have to multiply this by the derivative of the inside, which I have to use the product rule. So x is the first function, y is the second function. So first I start with x. So the derivative of x is just 1. So this will be 1 times y. And then for the other part of this will be x times 1 dy dx. So hopefully this makes sense, right? So I take the derivative of y, and then that's where the dy dx comes in. Okay, so there's one side. So now moving on to the other side, I have to use the product rule again. So the derivative of x squared is 2x, and then I leave the y to the 5th alone. And then I've got x squared times 5y to the 4th dy dx, and so there we're good to go with that. So now I've got to try to clean this up a little bit, and then I also want to distribute this stuff here. I need to distribute that to the sine of xy. So here's a pro tip if like trying to multiply this together is just totally throwing you off. That happens a lot with implicit differentiation. Reverse the order of this. So let me show you what I mean. So I've got 6x to the 5th, and then this is y plus x dy dx times sine of xy. So see how, let's see, sine, let me put the parenthesis here, sine of xy. So for some people, by rewriting it like this, now they can kind of see how to distribute, because you can't distribute anything into the xy. This is sine of this function, so this you have to kind of leave alone. So you have to just distribute these things to the front, and sometimes that throws people off. And you could even draw, you know, back from the days of algebra or whatever, drawing like your little distribution sign so that you remember what you're trying to do. That's another option, because for some reason this can really mess with people's heads sometimes. So I've got 2xy to the 5th plus 5x squared y to the 4th dy dx on this side. Okay, so if I distribute this, let's see, I think I'm going to start running out of room here, but I'll do my best. So I've got 6x to the 5th plus y sine of xy. So notice how that y just got distributed to the front. And then for this next part, so it's kind of up to you where you want to put the dy dx. I know it can be a little problematic. So if you want to put it in the very front, this could be dy dx sine of xy. So notice how I kind of distributed all of this to here. And then this equals 2x y to the 5th plus 5x squared y to the 4th dy dx. Okay, so we're still not done, right? So now I need some more room. Okay, so now I've got lots of space, and so just notice where my dy dx is. So I need really this term here, and I need this term here. I need these two things together, everything else I need on the other side. So I am going to bring this term over to the other side, and these two terms I'm going to bring over. So let's see. I have dy dx times x sine of xy minus 5x squared y to the 4th. So like I said, I'm bringing this over to the other side, and I just took out the dy dx. This is going to equal 2x y to the 5th minus 6x to the 5th minus y sine of xy. And so actually now this is simple to finish, so it's kind of a lot to look at, but once you kind of figure out where your dy dx is and you factor it out, then usually the last part is just division. So my final answer in this case is going to be dy dx equals 2x y to the 5th minus 6x to the 5th minus y sine of xy over x sine of xy minus 5x squared y to the 4th. And now we're done. So now for this last one, so more product rule and chain rule fun. So for this one, so as I take the derivative here, so I have the product rule, so these are my two pieces, and then I'm going to have to use the chain rule on this, and then I'm also going to have to use the product rule here. So here with the product rule, here's one, here's the other. So if you want to pause the video and try this, highly recommend you do that. It makes the whole experience much better. Okay, so the derivative of, so starting with this side, so the derivative of y is 1, so I'll write the 1 there as a placeholder. And I'm going to multiply that times cosine of 3y, and because I took the derivative of y, this becomes dy dx. Now I leave the y alone, and I take the derivative of cosine of 3y. So this I have to use the chain rule. The derivative of cosine is negative sine, and I leave the inside intact, and then I multiply that by the derivative of the inside, which is just 3. And since I took the derivative with respect to, or I took the derivative of y, I write dy dx here. So there's the left side. And so now on the right side, let's see. So the derivative of 1 is just 0, so now I'm just really going to fuss with this. So let's start with this negative 4x. So the derivative of x will just be 1, so this will be negative 4y, and then minus negative 4x. So the y drops out, and because I took the derivative of y, I write dy dx. Okay, so now let's just work on kind of cleaning this up. So I've got cosine of 3y dy dx minus 3y sine of 3y dy dx equals negative 4y minus 4x dy dx. And so this one's not going to be too bad in finishing off because we don't have to distribute or anything. So in this case, here's a dy dx, here's a dy dx, and then here's a dy dx. So I really just have to bring this dy dx over to the other side. So if I do that, let me clear some space. So I have cosine of, let's see, actually I'm going to factor out the dy dx. So I'll bring dy dx out. So I'm left with cosine of 3y minus 3y sine of 3y. And then notice I have to add the 4x over to get it on the other side. So this will become just plus 4x. All of this will equal negative 4y. So then I just divide out by that last part. So I get negative 4y divided by all of this good stuff here. Sine of 3y plus 4x. Whew, okay. So implicit derivatives, super fun, right? They are a little bit dizzying, so you do have to really pay attention to kind of when you're distributing and stuff like that. Definitely take your time. And that'll do it for this video, although I do have lots of other videos you can check out. So hopefully I'll see you guys next time.